Assalamu alaikum. Hope all of you are doing well. Today we are going to study acids and alkali. That is chapter 14 of your chemistry book, Chemistry for You. So let's start our lecture. The major points that we will discuss today is what are the acids, some properties of the acids, some examples of the acids. What are the alkalis, some properties of the alkalis, and some examples of the alkalis. And in the end, we will discuss how to distinguish either the given solution is acidic or an alkali. So let's come to the first point of our presentation. What is an acid? Whenever you hear a word acid, the first thing that strikes your mind is it is something very dangerous. It has corrosive effect, it has burning effect, or it has fuming effect. Although this is true for most of the acid, but it is not true for all the acids. Some acids are strong and some acids are weak. Before going into the detail of strong and weak acids, first of all, let us explore the meaning of the word acid. The word acid came from the Latin word acidus, that means sour. Yes, all the acids are sour. The degree of sourness depends upon the strength of the acid. Weak acids. Some of the acids are very weak and we can consume them in everyday life, and some of the acids are even produced by a human body. For example, here is a picture of a vinegar. Vinegar contains ethanoic acid. This is the very same vinegar that we use in our fish and chips and soups. The next acid that we are going to study is a weak acid known as ascorbic acid. This ascorbic acid is present in the vitamin C tablets that most of the people consume. Then the next acid we are going to study is the carbonic acid. This carbonic acid is present in all the fizzy drinks. For example, Pepsi, Sprite, 7-Up, and Lemon Up. Last but not the least, citric acid. This acid is present in all the citrus fruits, for example, oranges and lemons. Now, let us discuss acid rain. Carbon dioxide present in the atmosphere, when mixes with the rainwater, it forms a carbonic acid, which is very harmful and is termed as acid rain. So, in the countries where the concentration of the carbon dioxide is very high, the carbon dioxide, when mixed with the acid rain, a large amount of carbonic acid is produced and causes the acid rain. This acid rain is very harmful for the forest. Look in the picture how it has ruined a forest. It also affects the marine life and causes the death of many fish. It also affects the building. Strong acids. Strong acids are those acids that are mostly used in our laboratories. Even when we use these strong acids in the laboratories, we mostly dilute them, which means that we add water in them. Some of the strong acids are used as concentrated acids. That means they have low water content and high acid content. These acids are specifically very dangerous and should be used with greater care. Some of the common strong acids are sulfuric acid, hydrochloric acid, and nitric acid. Before I proceed further, I want you to pause this video for a while and memorize the formula of these three acids, H2SO4, HCl, and HNO3, because these three acids will be studying in the rest of our chapter. So, acid, as I told you earlier, our human body produces an acid. The acid produced by our human body is known as hydrochloric acid. What is the function of this acid in our body? This acid kills the bacteria present in our food. Plus, this acid also helps to digest the protein we eat. I hope almost all of us have the feeling of indigestion and burning sometime in our life. Why there is this feeling? This feeling is because our stomach produces excess of hydrochloric acid, due to which we have a feeling of burning. Now come to the other part of our presentation, that is alkali. Alkalis are the group of chemicals that are chemically opposite to the acids. So alkalis can cancel the effect of an acids. Alkalis are mostly bitter in taste. That doesn't mean that you start eating these alkalis. So most common alkalis are soap, washing soda and baking soda. As I have already told you that HCl in excess in our stomach can cause burning. So to cure that burning, we should eat a tablet containing an alkali, because alkali can cancel out the effect of acid. So the burning effect of HCl can be cancelled out if we consume any alkali, and the process in which an acid and a base cancel out each other effect is known as neutralization. Now, let us study the process of neutralization in detail. Acids and alkalis, when mixed with one another, as shown in the diagram, they cancel out each other's effect. And when they cancel out each other's effect, a solution that is formed is known as neutral solution, and the process is known as neutralization. We will study neutralization and what it leads to in further lectures. Now, we should have a method to distinguish why either the given solution is alkali or an acid, or if it is acid, either it is a strong acid or a weak acid, or if it is a alkali, either it is a strong alkali or a weak alkali. For this purpose, we have a scale known as pH scale. The word pH stands for power of hydrogen ions. So, a pH scale is a scale that is used to measure how acidic or alkali a solution is. So, look at a typical pH scale in the figure below. It has a number from 0 to 14. The smaller number from 0 to 6 stands for acids. 0, 1, 2, 3 for strong acid and 4, 5, 6 for weak acids. The number 7 stands for a neutral solution. And from number 8 to 14, it shows alkali. 8, 9, 10 for weak alkalis and 11, 12, 13 for strong alkalis. So as you can see here, the number 7 is given to the neutral solution, that is water. The number 2 is given to the hydrochloric acid produced in our stomach. Number 4 is given to the acidic rainwater. Number 9 is given to an alkaline washing powder. And number 12 is given to a strong bleach, that is strong alkali. Now, how to determine a pH of a given solution? The pH of given solution can be determined by adding an indicator. An indicator is something that changes its color when it is added in acidic or alkaline solution. The most common indicator that we usually use is a litmus paper. This litmus paper, when added in an acidic solution, turns red, and the color on the litmus paper is then matched with the color on the pH scale to determine either it is a strong acid or a weak acid. And the litmus paper, when added in an alkali solution, turns blue. The color of the blue litmus paper then compared with the blue chart of the pH scale to determine whether it is a strong alkali or a weak alkali. Hope you understand all the concept of the chapter. In this lesson, we studied acids, their examples, alkalis, their examples, and how to determine either a given solution is alkali or acids. So, if you have any questions or queries, you are always welcome to ask. Thank you.